Hello, Mr. Colati here, and today we are going to learn the quotient rule, which is the sequel to the product rule. So let's get started. This is a function which is a quotient of two functions. Remember, quotient means division. You can't just take the derivative of the top divided by the derivative of the bottom. You have to use the quotient rule, which, if we look at it, is a little bit more complicated than the product rule. It's g prime times h minus g times h prime over h squared. So I like to write these things out in words, so let's think about this. The derivative of a quotient is, okay, so let's decode this. The g is the first function, or the top function. So it's the derivative of the first function times the h, which is the second function, minus, this time, minus the first function, g, times the derivative of the second function. Okay, all of that will be divided by the second function squared. So all divided by the second function squared. Phew. Okay, so that's kind of the, if you want to think about this rule in words. And again, as we're going to see, it's just like the product rule. It's more of a procedure. But the big thing to note here is that some people, when they teach product rule, they teach it in a different order, because order doesn't matter for the product rule, because you're adding. In the quotient rule, order absolutely matters, because there's a minus here. So let's try finding the derivative of this function f. It's the division, or the quotient, of two functions, so I have to use the quotient rule. So the derivative is the derivative of the first thing, which is x squared plus 2x minus 3, times the second function, which is x cubed plus 1, minus x squared plus 2x minus 3 times the derivative of x cubed plus 1, the second function. And that's all divided by the second function squared, which is x cubed plus 1, and let's put that all in brackets, squared. There we go. Okay, now this is a set of instructions. Now I can follow through. So the derivative of x squared plus 2x minus 3, well, that is just 2x plus 2 times x cubed plus 1 minus x squared plus 2x minus 3 times the derivative of x cubed plus 1. Well, the derivative of this is 3x squared. All of that divided by x cubed plus 1, all squared. At this point, all of the calculus is done. I've done my derivatives. So now I just have to do some algebra to clean this up, because it's a little messy. There's a lot going on here. What I'm going to do is, okay, I have to expand this, or FOIL this. And I have to distribute the 3x squared to each of these terms. So let me do this. Again, this is just algebra now. So this is 2x to the power of 4 plus 2x plus 2x cubed plus 2 minus 3x to the 4. Be careful with the negative here too, right? Because the negative gets distributed. So I have negative 6x3 and I have negative, negative, so that's positive 9x squared. Hopefully I did that right. And the denominator, and here's a big hint, usually you leave the denominator as is. A lot of students get really stressed out about how much do I have to simplify this, and usually you can leave the denominator. You're just going to simplify the numerator by collecting all the like terms. So we end up with 2x squared. So we have minus x to the power of 4, 2, 3 minus, so we have minus 4x to the power of 3. We have we're on x squared now, which is just plus 9x squared. We have 2x, and we have 2, all over x cubed plus 1 squared. And that's really it. I've collected my like terms. I'm not really going to touch the denominator, so that's it. That's done. That is my derivative. It's a complicated derivative, but that is the correct derivative. The slope of the tangent for that original function. So that's the quotient rule. It's a little bit more work than the product rule, but it has its kind of the same skeleton, right? It has the same kind of form. It's just got this extra thing in the denominator. One common mistake is to forget the denominator, so don't forget to do that. Okay, let's do a few more examples. So let's do this question here. It is a quotient of two functions, so I'm going to use the quotient rule. Let's go right into it. Now, again, you don't have to write this line here. It's helpful, maybe, especially when we're learning. But as long as you remember what to do, you can just write it all out in line. So the derivative of the first function, which is 6, times the second function, x squared minus 1, minus the first function, times the derivative of the second function, which is 2x, all over, and don't forget this, x squared minus 1 all squared. Now I need to expand and collect my like terms, so I get 6x squared minus 6 minus 12x squared. And that's all over x squared minus 1 all squared. So my final answer is negative 6x squared minus 6 over x squared minus 1 all squared. Now, let's look at this next question here. Again, it's the quotient law because I have a function divided by a function. And it's too bad because this is barely a function, right? It's just a constant. But I still have something on the bottom, so I can't really avoid this. So I have f prime is equal to the derivative of the top, well, the derivative of 5 is just 0, times the bottom, which is x plus 6, minus the top, 5, times the derivative of x plus 6, which is, well, derivative of x is just 1, all over the denominator squared. That leaves me, this cancels out because it's 0, so I end up with negative 5 over x plus 6 squared. Or you could have written this as f of x is equal to 5x plus 6 to the power of negative 1. Nope, don't do that for now. Sorry, that's chain rule. We're not there yet. Don't think about that. In fact, with a question like this, as it looks right now, we cannot really avoid the quotient rule. We can't even simplify this to get it out of the quotient rule. Consider, on the other hand, though, f of x is equal to x plus 6 over 5. This question, so if I had the inverse, or the reciprocal, I could rewrite this as x over 5 plus 6 over 5. That sort of question you could actually avoid the quotient rule, because I could find the derivative of this is just the power rule, and this is derivative, this is 0. So in this case, you can avoid the quotient rule. I mean, I would recommend to avoid it if you could, because it is a lot more complicated than the other rules. Okay, let's do this next question. Okay, so again, I don't like the square root sign. I'm going to write x to the half over 1 plus 2x. Okay, here we go. Let's find the derivative, dy dx. So, derivative of the first thing, which is half x to the negative half, times the second thing, minus the first function, times the derivative of the second function, which is just 2. All over the second function squared. Okay, now I have to simplify. So again, this gets distributed over. So I end up with, just be really careful with your algebra that you're not making any mistakes, right? The problem now is not calculus, it's just algebra. So I have half x to the negative half times 1 plus half x to the negative half times 2x minus 2x to the half over 1 plus 2x all squared. Okay, so let's try simplifying this now. So I end up with square root of, the x to the negative half, which is really 1 over 2 x to the half, right? Because that's in the denominator. Plus, okay, so these 2's cancel out. I end up with an x in the numerator and an x to the half in the denominator. So, I mean, if you want, this is x to the 1 and this is x to the half. So when you add these, you end up with just x to the half. Because I'm adding the exponents. Minus 2x to the half. And that's all over 1 plus 2x to 2. So these are actually like terms. So I have half and one of these, and I subtract 2. So I actually have minus 1. So my final answer becomes 1 over 2 root x minus root x over 1 plus 2x squared. Again, I don't want you to stress out too much about simplification, especially in IB. They really don't spend as much time simplifying as a regular grade 12 course. For my class, I want you to focus on no negative exponents in your final answer. So you should collect some like terms and then just make sure there are no negative exponents. I would accept this. Please don't let yourself be too stressed out about simplifying. Okay, let's turn the page. Now we can appreciate some of the great jokes. The derivative of this person is, again, they write it in this backward. No, yeah, they write it backwards, but derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. There you go. That's macabre. Okay, so now let's do the derivative of this quotient rule. So I have derivative of the top, which is 1, times, ooh, an exponential, natural exponent. 2ex minus 3 minus the top, x plus 2, times the derivative of the bottom. Ooh, derivative of this is just, okay, the derivative of 2e to the x is just 2e to the x. Remember how the derivative of the exponential is just the exponential. Then I have the derivative of the bottom, all squared. Now we collect our like terms. Remember to distribute this. So I end up with 2e to the x minus 3 minus 2x e to the x. That's the correct way to write it. You should put the x in front of the e to the x. Minus 4e to the x all over 2e to the x minus 3 all squared. Now collecting my like terms, I end up with negative 2x e to the x. 2 of something minus 4 of something minus 2 of that thing minus 3 over 2e to the x minus 3 all squared. So there is the quotient rule. We've done it many different times. You get these difficult questions. Just be careful about collecting your like terms. Note that it's often easier to rewrite the function before differentiating in order to avoid the quotient rule. So if you have a question like this, you could do quotient rule. But would you? What about instead Okay, let me rewrite this because this is very confusing. I mean, my first instinct is quotient rule, but if I rewrite it first, it should be x to the 4 over 3. So I'm going to get rid of the cube root there. And if I rewrote this like this, 9x to the negative 4 over 3, well, now this is much easier. I can use the power rule. The derivative is 9. Okay, it's not an easy power rule, but it's still easier than doing quotient rule. I bring the exponent down, so it's negative 4 over 3x, and then I have negative 4 over 3, and I have to subtract 1, or in other words, subtract 3 over 3. This gives me, okay, so now I can multiply this, negative 36 over 3 times x to the negative 7 over 3. Again, I just don't like the negative exponent, and I can simplify this. My final answer becomes negative 12 over x to the 7 over 3. There you go. That is the quotient rule. A little bit tougher than the product rule, but still the same sort of thing. You're going to finish the questions you did not do in the homework yesterday. So page 212, 1, 3, 5, 6, 8, 10, and 214, 1, 4, 6, 7, 9, 11, 15 to 18. Good luck, and we'll see you next time.